Hello, today we're going to talk about naming and writing formulas for ionic compounds. All right, first let's review how to classify ionic compounds. They always consist of a positive ion, called a cation, and a negative ion, called an anion. And typically the cation comes from a metal, but it could also be a polyatomic ion that has a positive charge, like NH4+. The anion could be a nonmetal or a polyatomic ion, something like carbonate with CO3 with a 2- charge. And the positive and negative charges attract each other, making it an ionic compound. And we always write the positive ion first and the negative ion second. Now let's talk about how we name ions themselves. Cations, which are typically metals again, you write the name of the element plus the word ion. So if I have something like Na+, we'd say that's a sodium ion. Or Ca+2, that's a calcium ion. Now anions, which are often nonmetals, you're going to change the ending to ide, IDE. So a good example, Cl- is chloride. O2- is oxide. S2- is sulfide. And there are others, but whenever you have a negative ion, you change the ending to ide. Now, if you have a polyatomic ion, they have their own names. And these are the ones that are given to you guys. So carbonate is always CO3 2-. And so if you see that in a compound, it's just carbonate. You don't have to change the name of anything. Phosphate is PO4 3-. Sulfate is SO4 2-. Nitrate is NO3-. Acetate is C2H3O2-. And chloride is ClO3-. Hydroxide is OH-. And ammonium is NH4+. Now again, anytime you see those exact formulas, this is their name, and you're good. Now there are some ways that we could change those formulas, and when those formulas change, we have to change their names. So here are the rules for changing the names of polyatomic ions. If you add an extra oxygen to the polyatomic ion, then you add the prefix per to the front of the name. If you have one fewer oxygen, then you change the ending to ite instead of ate. And if you have two fewer oxygens, you add the prefix hypo, and the ending is still ite. Okay, so let me give you an example. I have, let's do sulfate. SO4- SO4 2-, excuse me, is sulfate. And that's the normal formula for sulfate. If I have an extra oxygen, SO5 2-, this is persulfate. I added the prefix per. If I have one less oxygen, I change the ending to ite. So instead of sulfate, now you change it, it's sulfite. If I have two less oxygens, so SO2, I add the prefix hypo and change the ending to ite, hyposulfate. Now notice that the charge doesn't change, it's always 2- for all of these. And you can follow the same pattern for any of those polyatomic ions that end in ate. If you change the oxygens, it will change the name of the polyatomic ion. Okay, so now let's practice assigning names to binary ionic compounds. Let's start with a simple one, one that you probably have seen before, NaCl. So for the first element, you always write the name, so it's sodium. We call this binary because there are two elements in that compound, only two elements. So sodium And then Cl, remember when we changed the negative ion, we changed the ending to ide. So instead of chlorine, it's chloride. Let's try one more. If I have, let's do MgO. Mg is magnesium. O is oxygen, but since it's in the compound and it's an ion, we're going to call it oxide, magnesium oxide. So that's it. Binary ionic compounds are the simplest. Now, if you have a compound with a transition metal, it's a little bit different. Transition metals can have different charges based on the compound. And so we have to use what it's attached to state what the charge is. So we're going to use Roman numerals to give the charge on the element because they have different charges. Now, Roman numeral 1 would indicate a 1 plus charge. Roman numeral 2 indicates a 2 plus. 3 indicates a 3 plus. And 4 is IV, which indicates a 4 plus charge. So let me give you a couple examples. I'm going to use iron as an example here. Let's do FeCl2 as my example. And then we'll also do FeCl3. Okay. Now, chlorine is a halogen. Halogens are in group 17. They have 7 valence electrons. They only need 1 more to fill up their shell. So I'm going to actually draw this one out. I've got chlorine and iron. So chlorine just needs 1 more to fill up its shell. It's going to form a 1 negative charge. And there's 2 chlorines. That means the iron must have a positive 2 charge to balance out those 2 chlorines. We have to state, with using a Roman numeral, what the charge is on the iron. So how we do that, we write the word iron, and then we use parentheses 2 chloride, because the 2 tells us that the charge on the iron is plus 2. For FeCl3, this time I have an iron that we don't know the charge of, and I have 3 chlorine atoms, 3 chloride ions. So they all have a charge of -1, because halogens always form charges of -1. And overall, they have a charge of -3. To balance that out, the iron must have a positive 3 charge. And so this compound has the name iron 3 chloride, because that 3 tells us the charge on the iron is positive 3. So you always need to look at what it's attached to figure out the charge on the transition metal. Okay, you might be asked to name an ionic compound with a polyatomic ion. Well, let's look at a couple examples. Let's do like CaCO3. Name the element, calcium, and you just name the polyatomic ion. CO3 is carbonate. It's always carbonate. You don't have to change it at all. But if I have CaCO2, that's 1 less oxygen. Make sure you use those prefixes and suffixes. When you change the oxygen, it changes the name. This one is now carbonate, calcium carbonate. You might also have a polyatomic ion with a transition metal. So if I have something like FeCO3, the charge on carbonate is -2. That means the iron has to be +2 to cancel it out. Anytime you have a transition metal, you have to list the Roman numeral for the charge. So because this is +2, you have to use the Roman numeral 2. CO3 is always CO3, it's always carbonate. So we just write iron 2 carbonate. Here's a few more examples. So CaS. I always check, is the metal a transition metal? Calcium? No. So I can just write calcium. And then S, we change the ending to ide, so sulfide. I don't need a Roman numeral because it's not a transition metal. The next one, Al. Al is aluminum. Cl is chlorine, but we change the ending to ide, aluminum chloride. And again, we don't need a Roman numeral because aluminum is not a transition metal. Now we have zinc here, Zn, zinc. Now, zinc is a little funny. Zinc is in the transition metal section of the periodic table. However, zinc always forms a 2+ charge, always. So we don't need to use a Roman numeral for it because it always has the same charge. So in this case, we could write zinc iodide. But because it's in that transition metal section, if you accidentally write zinc 2 iodide in honors chemistry, I'm okay with that. But just so you know, zinc always forms +2 charges, so we don't really need the Roman numeral. Now the next one, we have a polyatomic ion, SO4. So let's name this first one. Na is sodium. It is not a transition metal. And SO4 is sulfate, so it's just sodium sulfate. Now CO is cobalt. Cobalt is a transition metal, so I will need a Roman numeral. Let's look at the next part to figure it out. SO3 has one fewer oxygen, so I can change the ending of that to sulfite. But the charge is still the same. It's still -2. Just like this sulfate is -2, sulfite is also -2. So cobalt must be +2 to cancel it out. So it's cobalt 2 sulfite. Alrighty, now we can also go backwards. If I give you the name, you can be able to write the formula. And we've practiced this before in the second section, just on ionic compounds, but let's kind of put it all together. Magnesium nitrate. Magnesium is Mg. Okay. Magnesium is in group 2 on the periodic table. It has 2 valence electrons, so it can lose those 2 and have a +2 charge. Nitrate is one of your polyatomic ions. It's NO3 with a 1 negative charge. Those do not match. I need an extra nitrate to balance it out. And so now I have matching charges. I can write the formula. I took 1 magnesium and 2 nitrates to make my compound. The next one, iron 3 sulfide. Iron, they told us here that the charge is +3 because it's a transition metal. Sulfide, see the ide, that tells us it's just S. S is in group 16. It has 6 valence electrons. It wants to gain 2 more. Now those charges do not match. I need to, if I add another S, now it's -4, +3. +6, I need another one, -6. Now the charges match. And so it took me 2 irons and 3 sulfurs to cancel out. So that is my formula for iron 3 sulfide. Last one here, copper 2 chlorite. Copper is Cu, and they told us it has a charge of 2+ because it's a transition metal. Now chlorite. I like to start with chlorate because that's like the base one. Chlorate is -1, ClO3, but the ite at the end makes it lose an oxygen. So it's ClO2. Then I need to check the charges. They don't match. I need to use an additional chlorite ion to get the charges to match. And I would write my compound as CuClO2, 2, because it took 2 of those chloride ions to balance out. Now let's talk about acids. Acids start with hydrogen. And we're going to say except for water. Okay, remember that water can sometimes be written as OH2. Technically, water is a very weak acid. It is the weakest acid, but we will get to that when we talk about acids and bases. We do not name water that way, so we're going to keep it here. So anything that starts with hydrogen except water is going to be named as an acid. Right? Now, let me give you a couple examples. If I have HCl, let's do H2S. Okay. If you do not see oxygen there, you're going to use the prefix hydro, the ending ic, and then comes the word acid. So let's look at HCl. It starts with an H, so I know it's an acid, and it has chlorine in it. So I name it as hydrochloric acid. Prefix hydro, ending changes to ic, acid. Hydrochlor, because it's chlorine, ic, acid. H2S starts with a hydrogen, it's an acid. This one is hydrosulfuric acid. Hydroic acid. And so these are the rules you'd follow if there is no oxygen. Now, there are slightly different rules. If you do have oxygen, they're called oxyacids because they start with hydrogen. And they also have oxygen. These ones do not use the prefix hydro. When you have an oxyacid, if the ion ends in ate, the ending changes to ic. If the ion ends in ite, the ending changes to us, O-U-S. And I'll show you what I mean. If you have something like H2CO3, CO3 is carbonate. It ends in ate, so I'm going to change that ending to ic and add the word acid. I'll do another one. HClO2. ClO2 is one less than chlorate, so it's chlorite. One less oxygen than chlorate. It ends in ite, so ite changes to us. So this is chlorous acid. And for both of them, we always add the word acid at the end, because that word acid tells us that there's a hydrogen at the front. So we've got carbonic and chlorous acid there. So here's just a few more acid examples. Notice that there's no oxygen, but it does start with a hydrogen. So when there's no oxygen, we use the prefix hydro. And this is phosphorus, so phosphoric. Hydro always goes with ic. And then we add the word acid. Hydrophosphoric acid. Now for this next one, you do have an oxygen, so we don't use the prefix hydro. We need to name SO3, which is sulfite, because it's one less oxygen. And ite changes to us when we're naming the acid. And then we have the word acid. Now, because sulfurous acid sounds a little funny, you will typically see people write sulfurous acid instead of sulfurous acid. So that one is the more common spelling there, sulfurous acid. Now, the last example here, we've got NO2. NO3 would be nitrate, but NO2 is nitrite. And because ite changes to us, it becomes nitrous acid. And that one is exactly as it's written, nitrous acid. If you had HNO3, that would be nitrate. Ate changes to ic, nitric acid. And so that's how we name acids.